Now that we've seen how to use the pole method to calculate shadows, let's move on to a little more complex object. Here we have a box, similar to the cube we did in the first part, but now we have flaps. This will make the shadow more complex. We've already done a cube, and we used 4 poles like the ones I've shown here. But now with the flaps, we're going to have to drop in other poles and angles down and ground angles. You can see I've kind of put 2 in here to give you an idea of how they would be. Notice that this corner right here, because it's on a flap that lines up with this side of the box, the base of the pole would hit a line that comes along the bottom of that side. Likewise, this pole is on from a flap that lines up with this side, whose baseline is here, so it stops at that baseline. Let's calculate the shadow right here to begin with. Ground angle, and we have the line coming down that shows where it would stop. This gives us the end point of this pole, which also represents the shadow from this corner. Here's the corner. Here is where that corner shadow would be. Now let's move onto this side of the flap, and we'll do it on this side. Again, pole, ground angle, angle down, giving us a point which represents the shadow of this tip of the flap. Now we know these 2 points are connected and would have a shadow, so the 2 points on the ground would be connected, and this would represent the shadow of this edge right here. Move around to this corner. We put in another pole. I drop in the ground angle, the angle down, and we find another point. And we know this point and this point have an edge between them, so there'll be a shadow between these 2 points. Next, we'll move up this edge to this corner. Already have a flagpole in it. We have a ground plane and the angle down, so we know that its endpoint's right here, and just as these 2 are connected, the 2 on the ground will be connected. Moving around to the other side of the box, we use the pole right here, calculating its point right here is here, and because these 2 are connected with an edge, the shadow will be connected. Continuing on down to this point, we drop in a pole. Note it lines up with the edge of the bottom because this edge of the flap is the same as this side of the box. Ground angle, angle down. This gives us the point that represents the shadow here. This shadow is connected to this shadow, which is represented by this. Now we'll move down along this flap to this end. We put our pole in, ground angle, angle down, and we find the point that represents the corner of this flap. And this corner and this corner are connected, so this point and this point, which represents this, will be connected. Moving along the edge of the flap, we come to here, which would have a pole like this, angle down, ground angle, and you find the point that represents the top of this corner. Now, again, we know that this corner and this one are connected by an edge, so they'll have a shadow edge. Now, this is where it's going to get a little tricky, so follow along. This point is inside the box. So the shadow would go from here to here, but it hits the box right there. So we know we'll see this line right along here. hits here, then the shadow has to go to this corner as it travels up the side of the box, like this. And we wouldn't see all of that shadow because the flap would be in the way. We only see this much. Let's go back around to the other side and we'll finish up the shadow over here. We found this point, which is down here, and now we're going to travel along here and find this corner of the flap. What point on the ground does it make? Put in a pole. It hits the ground along a line that is equal to the baseline of the box on that side. We drop the ground angle, the angle down, and we find the point that represents the shadow of this corner right here. We know that this point and this point are connected by an edge, so the points that represent them on the ground will be connected by a shadow line. Now we'll move back to the box itself, to this corner right here, put in a pole, find a ground angle, find the angle down, and we find the point that represents this on the ground. And we know that these two are connected. So there will be a shadow line from this point to where this point is on the ground. We have a box, and this point's behind the box. Now the angle would be correct because this is how much we see. We just wouldn't see the whole thing. We'd only see this much. Now we have the base shadow as it goes around the box. Now this seems to be about all the shadows, but there's one more. If the light's coming down at this angle, inside the box this is going to be in shade, and there'll be a shadow line somewhere on this side of the box. We can calculate that just as we found this one here, but this is where you can use logic. If this one is this angle, and we're dealing with an isometric view, the one over here will be the same. It'll be like this. We've used the pole method in this isometric drawing, knowing the ground angle and the angle down, to find the shade and shadow. Remember, using your poles, you find this corner's shadow on the ground, this corner's shadow on the ground, this one, this one, this one, and the others, until you can calculate from point to point what the shape would be. It's the same with any complex object. You just have to work out where to put your poles. Here's your box with flaps in shade and shadow.